there's two ways to look at these problems. And you tell me how your teacher is looking at them. One way is to figure out the total surface area to be covered by the wallpaper.
Okay.
Let's do it that way. What's the surface of wall number 1?
Is that 10 by 13?
About wall number 2.
Wall number 2 is 11 by 10.
Wall number 3.
11 times 33 for that one.
Not 11.
10, sorry.
And the height of each wall is 10. And wall number 4.
That one would be 11 by 13.
Okay. Or, again, 10 by 11.
Okay.
In other words, each of these rectangles is 10 feet high. Rectangle number 1 is 13 feet by 10 feet. Number 2 is 11 feet by 10 feet. So forth. Okay? So those total 480 square feet that we have to use. How much square feet is each roll of wallpaper?
It's 2.5 by 15, so that'd be
125.
Okay.
Right? 2 times 50 is 100. A half times 50 is another 25. 125.
Yeah.
How many rolls of wallpaper do we need?
For one side or the whole thing?
For the whole thing. In other words, the final question is how many rolls should he buy? Well, what's the straightforward way to figure out how many he needs? I've got 480.
Yeah.
I got 480 square feet to cover. Each roll has 125 square feet in it. How do I find out how many rolls I need?
Divide 480 by 125.
What do you get?
3.84, so you have to round it to 4.
Yes, because you can't buy a 0.84 roll of wallpaper, so you'd have to get 4. Now, I don't know if it's helpful or not, but there is another aspect to this problem, and that's why I say, tell me if your teacher has addressed it. If it's wallpaper, it doesn't really apply. But let's say it's bricks. And we cannot cut a brick in half. Then there is the issue as to whether the bricks fit evenly or not. In other words, you might not be able to take just the square footage that needs to be covered and divide it by the number of, or the square footage of the bricks because of that partial amount. Well, if I look at this problem, I can see that this wallpaper is almost perfectly going to cover. If I lay the wallpaper like this, right, that's 2.5 feet that way, then it perfectly covers one wall up to down, and that would be 13 feet, would take up 4 rolls. I take all 4 rolls around the top. Each roll covers 11 plus 13 plus 11 plus 13, 48 feet. Each roll is 50 feet long. It's almost perfect. In other words, you can come up with 4 rolls if you are able to visualize this properly. You're not going to put the rolls up and down, Notice that that's a problem here. If I unroll the wallpaper and I lay it vertically, so that there's my 2.5 feet, notice that it doesn't fit precisely in my 13-foot long room. 5 rolls would still leave a 1/2 foot space right there. How are we going to cover that space?
You can't cut it, can you?
No, not well. Like I said, with wallpaper, you wouldn't ever cut it like that, but you possibly could because it's wallpaper. But that's why the problem's a little different if we're talking about something like bricks. But even still, nothing says we have to lay the wallpaper vertically. If we lay it horizontally like this, notice that exactly 4 rolls make up the 10-foot ceiling. 4 times 2.5 is 10. With nothing wasted, nothing left over. And so what I basically do is take roll number 1 and string it around the entire top of the room.
Okay.
And that takes up 48 feet, the perimeter of the room, with just 2 feet of wallpaper left over. Well, that 2 feet ain't going to do you much good. You can't really use it to help things. So just buy 4 rolls and string them all around the room like that. Whether or not any of these problems will require us to think like that, I don't know. I haven't had a chance to look at it. But this problem is fairly straightforward. If you just do a total surface area needed covering divided by the surface area of each roll, you get this number, and you know you have to round up.
Okay.
All right. Ooh. Don't tell me this is a work problem. I haven't come across a work problem in a long time. Let's see. What's the square footage to be covered in each room? Let me go back to that picture. Change the dimensions. Still 10 foot high. That's actually the standard height on rooms and hotels and everything else. But in this case, it's 14 by 16. So now you have to paint the 4 walls plus the ceiling. So let's come up with a square footage.
Okay. So the ceiling is.
And wall number 1 is what?
10 by 16.
160. And wall number 3 is the same thing. What's wall number 2?
That'd be 14 by 10.
And wall number 4 is same thing. And what's the ceiling?
Is that 16 by 14?
Correct. What number is that? That's 160 plus 64, 224. Okay. Is that right? Let me get my calculator.
Yep.
Okay, good. Now, if we add all those numbers, we have 300 and 300, 600, 824 square feet. How many rooms are there?
148.
So 824 times 148 equals 121,952 square foot that needs to be painted. Each one with two coats. But let's try to answer area number one. Calculate the total area of all surfaces to be painted with one coat. We just did it.
Okay.
121,952. Part B. 1 gallon of paint covers 500. How many gallons of base paint are required for this job? You should probably be doing these calculations on your calculator so that you'll be ready for each subsequent problem. But if I take that answer there and divide it by 500, right?
Yeah.
Ooh, hold on, I did something wrong. 121,952 divided by 500 equals
244.
Yeah, 243.9, which rounds off to 244 because you can't buy part of a gallon. Okay. 1 gallon of finish paint requires 250. How many gallons of finish paints? Can you do it quickly?
121,952.
Wouldn't it be twice as much?
Yeah.
In other words, the other answer was actually 243.9. Rather than taking this number and dividing it by 250, which is what we would normally do, it doesn't have to be twice as much. It has to be twice as much as this number. Because we're dividing by a number that's half of 500.
Okay.
See why it has to be twice as much? So,
yeah.
This all I got to do is double that. 488. Now, that would be a little dangerous with round-off error. And this is a good illustration. First of all, do you follow me what I'm talking about? As to why we don't have to do the calculation? In other words, if it takes 244 gallons to cover where each gallon covers 500, well, this paint, each gallon only covers half as much, so we must need twice as much.
Okay.
Well, let's go back. I just want to illustrate something here. Let's say this number was not 9, but 0.49. Well, we would still need 244 gallons to lay down a base paint cover, right?
Yeah.
But now, when I double that number, I don't get 488, I get 487. And 487 would be the correct answer. See why?
All right.
Okay.
Yeah. Yeah.
Okay. And, of course, if your life depended on it, you'd probably go back to this number and divide it by 500 or 250 and then round it up. But there can be a little bit of a danger if you multiply. In other words, if you round up early, sometimes you get round-off error that accumulates, and you end up with a wrong answer on the final question.
Okay.
I don't think we're going to have time to do all three of these. Do you have a preference? Probably be able to do two of them.
4 and 5.
Okay. Then we'll go back and do 3. Let's see. 4 really is not going to be that hard. 4 is a carpeting problem, which means 4 is only about the area of each of these rooms and hallways and bedrooms. Right?
Okay.
So the problem on 4 is going to be calculating the area of each room. And it looks like the carpeting is the same regardless of where it's installed. Yeah, the carpeting is all $14 per square yard. Let's do this problem just to catch against one thing that I see as a potential problem. Is that your dog? No, that's my dog, isn't it? That sounds like
Yeah.
my dog, yeah. That is. What's the square footage of the bedroom?
Bedroom would be 8 by 13. That's...
This bedroom right there. The upper left.
Oh, okay. 90.
What is it?
90 feet.
90 square feet. What's the cost going to be to carpet that bedroom at carpet being $3 per square yard for the padding and $14 per square yard? How much is it going to cost me to carpet 90 square feet?
Is this including installation?
Sure. In other words, they're basically, in other words, it's $20 per square yard, right?
Yeah.
Question really becomes, how many square yards is that? In other words, that's
30.
feet. How many square feet are there in a square yard?
There's 3 feet in a yard, so...
So how many square feet are in that square yard right there that I just drew? That's 1 square yard.
Is there 9?
Correct. 9 square feet per square yard. So how many square yards is this?
This one would be... That'd be 10, then. So it'd be $200.
Correct. For that one room. What will it cost her to carpet the 3 bedrooms and hallways? Ignore the thickness of the walls. So this problem is going to be taking that yardage, that, oops, not the bathroom, 3 bedrooms and the hallway. The hallway, the bedrooms are easy enough to figure it out. What are the dimensions of that hallway? Or what's the area of this hallway? Here, let me, this is a little tricky. Let me draw it. What's the top width?
That would be 6 feet across.
Which one is 6 and which one is 10 for the bathroom?
Oh, 6 is the,
short side.
like, yeah. So it'd be 10 feet across.
Okay. And what is this dimension right here?
Which one?
The one I've pictured.
Okay. Well, is it easier to calculate the whole thing and then subtract that, or?
It's pretty easy to come up with this width right here. What's this distance from here to here of this bathroom over here?
That's 9 feet.
Okay. What was this distance?
6. Okay, so that's just 3 feet.
3 feet. Okay. And
Yeah.
this distance here at the bottom.
So that's 10, that's 13. So that'd be. Is that also the 3?
Well, it's a little trickier to get this one. It's we need to know the distance from here all the way to there, right? It might say,
Uh-huh.
no, it doesn't, but we can figure it out. In other words, it's 10 feet from here to here. It's 10 feet from here to here. And it's 7 feet from there to there. So it's 27 feet from there to there. Well, if we go down here, it's 10 feet from there to there, and it's 13 feet from there to there. So what is that thickness?
4 feet.
Now, to figure out the area of that hallway, let's draw an imaginary line. Oops, we need one more distance. No, we don't. That's 6 feet right there. Let's see. We do. We need to know this distance right here. What's that?
Okay. So
that distance?
So that would be say for 8 plus 9.
8 plus 3. In other words, we've already figured out this width is 3 right here.
Yeah.
Well, it's 8.
That makes sense.
It's 8 from there to there, right?
Yeah.
To that point right there, that's 8. So it has to be 3 there. So that whole thing has to be 11. And now we have that hallway dimensioned to a point where we can solve it. And the way to do it is to break it up into 2 rectangles. Rectangle number 1, rectangle number 2. What's the area of rectangle number 1?
That'd be 44 feet.
44 square feet. And it's important to make sure you use the word square, because remember, we're going to have to convert this to yards. If you're converting yards to feet, you're going to use a 3-to-1 ratio. But if you're converting square yards to square feet, you're going to use that 9-to-1 ratio. What's the area of rectangle number 2?
30 square feet.
6 times 3. 6 times 3. 18.
36 square feet.
That's 18. Or just base times height. Area of a rectangle. Okay?
Yeah.
And once I've separated this L-shaped thing into 2 rectangles, well, then is all I need are the dimensions of each rectangle. Just do the base times width, add them together. What do we have? We have 62 square feet. Now, you don't want to convert each thing to yards as you do each room. The best way to do this problem is to add up the square feet of the bedrooms, the 3 bedrooms, the master bedroom, these 2 bedrooms, and this hallway. And then divide that by 9. That'll tell you how many square yards you need of carpeting, and then multiply that by $20 per square yard.
All right.
Okay? And that's pretty much standard in all of these problems. The only mistake you can really make is to not see that one measurement's in square yards and the other's in feet. So it's always worth looking for that. And that's about it, as long as you can figure out how to dimension each of these areas, because they don't give you the dimensions. You have to figure them out by doing what we did. And I don't see any other way to do it. I don't know. At no point do they give you a total distance across the top, so you have to figure it out. And you can't even tell on this bedroom here which is the 9 and which is the 10, because it appears to be a square. But on this bathroom over here, you can figure out that the 7 must be the width, the 9 must be the depth, and if the 9 is the depth, we can apply that to this bedroom over here. We know it has to be 9 from there to there, vertically. So you have to use some logic like that occasionally when you're doing these floor plans. And then, as you saw, figuring out the dimensions of the hallway were not that easy. Not that easy at all, in fact. Well, there's another way to do this. You can figure out the square footage of the hallway from square footage of the whole floor minus the square footage of each of these rooms. Leaves you the square footage of the hallway. But notice, to get the square footage of this part of the house, you'd have to know that that's 10 by 10 by 7, so that's 27 by 20. You'd have to use that logic. So there's a couple of ways you could do this problem. But I kind of like the way we did it the best, where you break down and you figure out the dimensions of this hallway. And by that I mean all of them. The width of each skinny part and the length of that part of the L and that part of the L. That's what you have to do. And it looks like problem number 5 is the same thing, only for a different part of the house. Remember, tiles, you're going to have to round up on that also. Okay. All right, Mark. We'll let you go and talk to you next Tuesday.
All right. Thanks, David.
You're welcome. Bye-bye.